So what we're going to do in this segment, I never quite get to do as many extra practice examples with you as I would like to. So I'm going to give you some exercises. I want you to pause the video, try this problem on your own, and then we'll go over it together. So coming back, I hope you recognized in this exercise that we need to take the natural log of both sides. All right, then we need to use our laws of logs to write this as this whole big long thing. All right, then I can take the derivative, right, using the chain rule. And remember, when I take the derivative of y, y is a function of x. So the derivative of the natural log of y is actually y prime over y, right? It's the reciprocal of y times y prime. All right, then this derivative would be 2 times 1 over this. Derivative of the inner is 2x plus 5 times 1 over 4x minus 1. Derivative of the inner is 4 minus 1/2 1 over x cubed plus 3x times the derivative of the inner, which is 3x plus 3. Now we're not quite done yet. We need to get y prime alone. All right, so in order to get y prime alone, we need to multiply both sides by y, but I don't want my answer to have x's and y's in it. So when I multiply both sides by y, I look up and say, well, what does y equal? What does y equal in terms of x? And so when I multiply both sides by y, I'm not going to rewrite this all, but I would end up multiplying by what y equals, which is this big function here that I began with. And as I mentioned in class, don't go crazy trying to simplify. Leaving an answer like this is perfectly acceptable. All right, so let's do logarithmic differentiation again in another setting. Let's look at what happens when I have a function to a function. So a function raised to a function. All right, so this is another case where I need logarithmic differentiation. So please pause the video and try this one. Now coming back, I hope you took the natural log of both sides. Then use my laws of logs that let me drop this down in front. Now I'm actually ready to take the derivative. So notice I haven't started taking the derivative yet. I've just been rewriting this. Derivative of natural log of y is y prime over y. And then on the right-hand side, I need the product rule. All right, so I need to do derivative of the first, which is 1, times the second unchanged, plus the first unchanged, times the derivative of the second. You may have done it in a different order, which of course is acceptable. And next I'm going to multiply both sides by y. All right, but I don't want to leave it as just times y, so I multiply it by, what is y in terms of x? All right, and so y is x to the x minus 1 times this in parentheses. So next example that I want to try, let's do a little bit more, let's start kind of easy with derivatives involving e. Okay, this one isn't too bad. but it does involve two different rules. I need both the chain rule and the product rule. So again, please pause and try this exercise. All right, so coming back, using the product rule, I would do derivative of the first, so that would be 1, times the second unchanged, plus the first unchanged times the derivative of the second. So when I take the derivative of e to the 5x, right, derivative of e is itself, but then I need to do times the derivative of the inner, right? So times 5. And I like to put my coefficients belong in the front, all right? So instead of putting the times 5 back here, right, I want that to go into the front. And this answer is acceptable if you factored out the e to the 5x, right? That's good also. So that would be the derivative. So now let's take a look at, for the next example, a very strange looking function, right? We don't see this a whole lot, but what if we had 7 to the sine of 5x plus x cubed, right? Not the kind of function we see every day. And to find the derivative of something like this, let me just remind you of our rule for finding the derivative of a to the x. All right, so remember that the derivative there is, well, actually, let me make this a to the f of x, right? Because this is certainly some base to a function of x. So this would be natural log of a times a to the f of x times f prime of x. Again, any order that you have this in would be fine. All right, so remember that this is our law for finding the derivative of a to some function of x. All right, so pause the video and try this one. All right, so coming back, in any order, I want to have natural log of 7 times 7 to that whole big power times the derivative of the function. And I purposely chose this to do a little Calc 1 review. So the derivative of sine of 5x, we do need the chain rule for that. So that would be cosine of 5x, but we have to do derivative of the inner, right? This is the inner function. So that would be 5 cosine 5x plus 3x squared. All right, and so if I want to put this all in parentheses, so that doesn't look very good, but that's a big parenthesis, so that it's clear that I have a product here. Next example, let's do one case of U substitution. So let's take a look at this example. The integral of (3 to the 4x squared). And just to remind you that to find the antiderivative of a to the x dx, right, what I get is a to the x over natural log of a plus c. All right, so this is the general rule that I'm using. So again, please pause and try this exercise. All right, so coming back, you should have let u equal 4x squared. So du equals 8x dx. And that works out well that I can multiply both sides by 1/8. All right, so now I can replace x dx, replace that with 1/8. Let me arrow over here, so that equals 1/8 3 to the u du. All right, and following the rule that I just reviewed up above, the antiderivative here would be 3 to the u over natural log 3 plus c. All right, and so then write this as, how about 3 to the 4x squared, I better move this up, over 8 times natural log of 3 plus c. So that would be my final answer. All right, so let's do one more exercise. Let's find the derivative of this function. All right, so as I like to recommend, I would suggest putting this in terms of natural log. All right, so again, pause the video. And coming back, I would have done this. And remember, when I go to take this derivative, let me write it like this. I'm going to separate this. This is a constant times natural log of 3x squared. All right, so using the constant multiple rule, ignore the constant for a minute, take the derivative, multiply the constant in at the end. All right, so the derivative would be 1 over 3x squared times the derivative of that, 6x, and multiply that by 1 over natural log of 5, which is equal to, so let's see, that would be 2, I'd have an x left, and I'd have a natural log of 5 left. And some of you may have noticed that when you're finding the derivative of natural log of 3x squared, if you wanted to, certainly we can write natural log of 3x squared as natural log 3 plus 2 natural log x, right? And then when I go to take that derivative, right, derivative of natural log of 3, well, that's just a constant, right? So the derivative of a constant is 0, and the derivative of this term would be 2 times 1 over x. All right, so that would have been another possible way to come out with this final example. All right, so there's some cases where to make life easier, you really want to use your laws before taking the derivative. This one wasn't too bad to just take the reciprocal and then multiply by the derivative of the inner, but it certainly could have been done the other way.